project at Barhale. And finally, Delta Civil Engineering working at Ramsgate on an 11-foot short tunnel, and also a crossing project for the A1 widening at Peterborough. In 1994, he returned to Barhale, and for the past 32 years has worked on numerous tunnelling projects with roles from site agent to regional manager. Before becoming chair of British Tunnelling Society in May 2022. He served as vice chair from May 2020 and was actively involved in the yearly organisation and delivering of the BTS Underground Design and Construction and BTS Underground Health and Safety courses for each year. In 2024, he kindly joined the Council of the North of England Institute of Mining and Mechanical Engineers and has served as honorary treasurer since 2025. He's also involved with the Midlands PID and is a committee member of Tunnel Skills. So, I've talked my way through that. What we really need to hear though is actually what Rod is going to present to us. So, can I give you Rod Young? Let's just get the right. Yep, that's got the right one. Right, thanks for having me along tonight. As Steve says, he's given my history. It's a very long one. I'm just on the, steadily on the way out now. I'm down to 3 days a week. So what I'm going to cover tonight is about handwork tunnelling, which is something that really started a lot of the tunnelling work in London 150 years ago. A lot of what you'll see in this presentation, especially the drawings, have come from a historical review that was put together by Colin Mackenzie. And then since that, presentations that have happened at the BTS courses, both by Colin, then Duncan Summers, then Roy Slocum, Richard Dexter and myself. So this presentation is a development that's been going on for about the last 25 years. So we're going to look at handwork and how it, especially in London Underground projects, has been used over the years. The tunnelling industry has lots of different ways of doing trenchless solutions, but this was definitely one of the early first ones. And for the, between 50 and 150 years ago, it was used very heavily. More recently, things have changed. We've got spray concrete lining, we've got machines that can work in small working areas these days, and there's a lot of issues with the use of the hand tools, the noise, and just the general backache and lifting of timbers and other various items, which I'll go on into in a little while. So it's also a big requirement to make sure that the temporary works, which is the timbering work, is also connected up to any permanent works that needs to be installed within the excavation that's been made by the handwork tunnelling. So it's looking, is there enough space for the permanent works? Can you install the permanent works in the space that you've been given? What are the lifting arrangements to be installed the permanent works? Because quite often the permanent works is a lot heavier than the temporary works that we're installing. Understanding the design life of the temporary works. Although it's behind the permanent works, is there any reason why, if there's voids left or if the materials aren't to the correct standard, it will degrade over a period of time and you'll end up with a void and you could end up with settlement. So you need to look at the settlement both from the temporary works and from the permanent works.
there's really two major sections of handwork tunnelling. There's the very basic square excavation, oblong excavation that's put in, which normally ends up being 50 metres long, or it used to be, or even longer at one stage. So what you've got here is you've got a typical excavation. You start from some sort of 2-3 metre square pit here, and you steadily progress your way along. There's lots of items that are used in this work, and there's two various ways of installing the timber work. Here you can see that the frames are all around about 1 metre apart. This is used more into ground that is semi-stable. If the ground is not that stable, you can remove these sideboards that you can see here, and you'll see that in some photos in a minute, and you can actually make the frames literally match up against each other. So you, instead of excavating 1 metre and then installing the next frame, you are literally building frame after frame, so you're only digging 9 or 12 inches, because everything, all this is still in the old measurements. So basically what you do at the pit bottom, wherever the pit bottom is, at the bottom of a shaft or bottom of a pit, you build this first frame, and then you drive these headboards above, and then you excavate and you build. So that is actually being your support and your protection while you're excavating below. Put the next frame in, put the sideboards in. There's lots of different items, all with different names. You've got your sideboards, your side trees, you've got your headboard, you've got a sill, you've got a kicker to stop the side trees coming in. So you've got a vertical piece of timber there which could, with some load on it, could kick in. So the bottom has a kicker to brace between the two side trees. You can put a top sill in if you wanted, or you can put in what, if you can just see there's a little bit of metal which is literally bent at 90 degrees twice. It's called a Yankee brob, and that saves putting putting a sill in at the top, so it's actually saving you some space, and it gives either a bit more working area for the people working in there, or what it does is it allows you to make the whole excavation a couple of inches smaller. These could be driven 20, 30, 40, 50, 100 metres years ago. But a lot of standards have been introduced over the years. And between the British Tunnelling Society and the Pipe Jack Association, this is the second revision of the standard. This covers how far you can go, both with pipe jacks, mechanised tunnelling of different diameters, but it also covers timber headings. And the standard now is that on any project, you shouldn't really do more than 2 timber headings at 25 metres length maximum. That is to save on the effects that it has on the workforce. So for any design team, they've got to look at other options to be able to install whatever's needed to be put inside this timber heading, rather than have more than 2 on a project, or more than 25 metres. If you've got to justify going for 30 metres or something, you've just got to, your risk assessments, the designer's risk assessments have got to highlight that. This document and the timber guidance The pipe jack one is available free to download on their website, and the timber guidance is free to download on the BTS website as well. Typical basic timber heading, driven. This particular one, these sideboards here have been put in after the excavation. So you've got your timbers at the top here that have been driven, and because the ground is stable, they've been able to leave that side unsupported until they've got to the next frame, and then they've dropped these in neatly. You can drive them the same way as you drive your top boards if you've got bad ground. So you're driving them ahead of where you're excavating. So you drive them in and then you excavate, and that's giving you the protection. These are mainly used for going a short distance, possibly from one side of the road to another, to find an existing sewer that runs down the road and you want to connect into it. So here you can see some sort of existing sewer must be going up and down the road. You've gone from one side across, done a connection, and then you lay the pipe back. Filling all this, and you'll see some more photos in a minute, filling all this with concrete as you come back, semi-dry concrete normally. You've got rails here that have been installed in 2-3 metre lengths, but to be able to advance forward, you've got a set of slide rails here so that the skips can be brought right up to the face. Very similar to the slide rails you use if you're using an IMCO loader in a mine at any point. This photo here shows where you're doing continuous framing without any sideboards. So you've got the continuous framing here, but here you've got the sideboards. So if you've got bad ground and you just need to be able to do it in stages, you do full framing like this. The other thing is also understanding how long it's going to be in place for. If you're going to just excavate 25 metres, put your connection in, put your pipe back in a week or two, fine, you can utilise this sort of, because it won't support the ground as well as a fully timbered structure. So if for any reason you're going to excavate that and you're going to leave it for a couple of months for whatever reason, you definitely need to be looking at a fully framed system. Here you can see one with angled side trees. You can see the kicker, the Yankee brobs here, which are stopping that side tree from kicking in by its bracing itself on the top of the head tree, and that's saving some working space or some excavation space. Here you can see a photo of a fully framed excavation. Another one, see the slide rails on the left hand side, timbering, that's got sideboards in between. Here you can see the headboards going in. They would be driven and then they'd be wedged on the top of the head trees, and you keep working your way forward, supporting the ground above you, putting in the next frame and moving forward. Clearer photo there of doing a connection, and you've got the slide rails again. You've got to look at the settlement here. You've got to ensure that the ground is supported as quick as possible after it's been excavated. So grouting does happen behind the sideboards and above the head tree and everything. Sometimes in this situation you've got a lot of gaps between the timber, so you need to somehow fluff up the gaps. That's normally used or done by a mixture of straw and grout, really thick, like brick mortar. Mix it together and it makes an incredible material that grout won't pass through. Something that's also used on the bottom of sinking, when you're sinking shafts, when you're trying to grout behind a segment in a shaft. Another one here with something like a 600 pipe being put into the heading that's been completed, and then filled with semi-dry. Then the next piece is put in, and then more semi-dry concrete is put in. Depending on the types of pipes you're putting in, you could put all the pipe in, block up each end, and fill with foam concrete under pressure. So there's lots of ways of filling the gaps. At one stage, there was a couple of trials trying to use a mixture of grout and broken up glass chips. So breaking old bottles up, thousands of old bottles up, and mixing the two together. It never really took off. Another typical one here, you can see the breakout from the bottom of a pit. You can see the steel sheets here, the whalers, and then the initial box out, and then steadily working off down there, and then working your way back. This one was get grouted up, so you've got a head wall put in here, supported head wall, and then it was grouted up. The two items that have always been used for doing any sort of tunnelling work in the past has always been the FL22 and a German jigger. Incredible bits of kit, especially the German jigger if you want to break concrete or rock. You've got to be able to how to use them. There's an incredible technique to using them. You don't try and lift them and try and do them above your head. You always try to lift them and let them, the weight of them, you hold them like that and let the weight actually cut the material. Great bits of kit, but then there was issues with the noise on them, and this is really going back to sort of 2000, and when the HABS rules came in about hand-arm vibration. So the idea was then to put mufflers on these. That reduced the white finger that could have been resulting from these, and also reduced the noise. But they're not as efficient, so it's a bit of a going round in a circle, because in actual fact you're having to spend more time using them to achieve the same amount of output. What was also implemented then was job rotation, so people were only allowed, depending on the HABS reading from these different items, they were only allowed to work an hour at a time. Then you had to swap them round. The result being you had to have more crews, more people in the team to rotate them round in a full 10 or 12 hour shift. So timber heading has become a lot more expensive because of trying still to use these bits of equipment. And white finger, I'll show you some photos in a minute. A couple of lads in Newcastle on the metro in the 70s using FL22s. They probably weren't the strongest of people, but they just got the right technique, and once they'd learnt the technique, it was so easy, and the production rates that you could get. I've had miners in a 1200 timber heading, we can get 2 or 3 meters in a day. it's a lot of, and you've got one miner in the there and one person shoveling. But this is why timber headings has been reduced, or different methods and other ways of doing them have been implemented. That's white finger, which comes from perpetual use of something that's got vibration from it. Those are some horrendous versions. I think a lot depends on how the people also looked after themselves. I've worked with some miners. I've got lads that still have spent years on the tools and they've got no white finger. I think it's a question of if they've kept themselves warm, their hands warm. It's when people let their hands get cold and how much time they've actually spent on them. But yes, some people, and I think it depends on the person, but some people have got horrendous results from using those tools. And the other one is hearing. If you've got one of those in the past, 50 to 100 years ago, nobody had earplugs. They had those tools going right next to their ears. And yes, that's caused a huge problem with some people. So starting to look at some more slightly complicated timber headings. When you start exposing the face to a larger face, you've got to look at how the load comes on and how the load comes on from both above and from the face. And a lot of the material that is being excavated is London clay or similar clays. You've got Cambridge clay and Gort clay. They're all very, very similar. But the London clay is the worst because it has what's called greasy backs in it, which are literally planes within the clay. And if you actually split the clay and find one of those greasy backs, there is actually a film of very fine grease. The result being that you've got to look at what the face is, what your ground actually has, how many fissures and greasy backs you can see, and then design the support. So this is a large excavation. So what's happened here is it's been developed through, and then you've got your fully timbered excavation coming behind, but you've also got a large big face. So it's supporting that face with your headboards coming forward here, bracing the headboard onto these front boards, supporting them, and you can see on some other photos they're actually stepped a lot more than that. They can be stepped 1/2 metre or more between each of the different stages as they work their way down, and that's all there to support the different areas that could slip. And again, you've got to look at whether that's a short-term design that you need or a long-term design, and how much support you need to do. Perhaps if you're breaking up for the 2 weeks of Christmas, you're going to have 2 weeks of loading there, so you need to look at additional support over holiday periods and weekends. Just a bigger detail of that last one. You can see everything detailed here, how it's all supported, and where the load is being put on to the unexcavated section before this piece is excavated. So this has just got one support across here and a whaler going across, and then you've got a light bit of timber here just supporting the last bit of material, but you've got a footing here and you've got a faceboard in here to hold this. Getting a little bit larger and more complicated. You can see how the excavation is going forward. You're having supports here to hold your side frames. And what normally happens is this is all excavated with timber, and then behind it normally is a installed cast iron segments or concrete segments. So this is just the temporary works to be able to then install them. And this is all used in areas where you're only looking to go a relatively short distance. You know, if you're going to go a decent distance, you employ a TBM, tunnel boring machine, with all the segments, all the pipes, to install that concrete lining. But you can see here the whalers, and then a staging for the workforce to be able to stand on the top section and take that front forward another metre, install that support, and then take down the working platform, and then take the bottom forward again, and then keep doing that progressively until they get to the end of the excavation. As you can see here, they're working on the face, and then they're putting in the cast iron segments. The typical way of supporting all the London Underground tunnels in London, 50 to 100 years ago, before concrete was started to be installed. They cement grout behind all this. Most of this London clay probably had moisture of somewhere between 25 and 30%, but it's very similar to other clays around the UK. Got to be very careful about drying out time, and if you're leaving the face that's timbered, but even here you can see that it's timbered, but you've got areas of clay visible. If that was going to be left for any period of time, they would actually bottle that up with a grout mixture to stop any moisture coming out of it and keep it all. Because of course, as soon as it starts drying out, you get the chance of more settlement from above, because there's the space to which that material can move into. Another version. And you can see here how they used to install within the timber headings the segments. They drop the segment onto the last one they've put in, which is the bottom one here, raise it up, and you can see I think there's 5 sort of working and 2 posing for the picture there. Pushing up those segments with flat caps on in the old days. Then they progressed to the plastic bump caps, and of course now they're not allowed to do it like that anymore. A lot of heavy lifting, not just on those segments, but the pieces of timber you can see. They've got to lift those up into place. They've got to produce the staging, the cross members, the side trees and everything. There's a lot of timber. But it's all about practice, a team working together. And I think that's the biggest thing that's always happened in the tunnelling industry and the mining industry. It's all about a team of people working together, which makes it a lot easier to install things. It's the training. People work their way up from just being an assistant, then you become a miner, then you become a lead miner. You learn everything on the way. It's about practice, it's about balance. It's putting in a lift plan, but not a formal lift plan like we have today, but they all knew exactly what they were to do. They all had the bolts ready to go in as soon as they got once they got the timber up, the Yankee rod was there to slip into place, or the wedge was to hold it all in place. Similar version today on Crossrail. So concrete segments put in, but these are getting lifted in by various other methods now. You've got frames there, you've got winches, you've got chain blocks, you've got various things so that nobody actually physically has to lift them all. And that's also installed to be able to install any face support or side timber at the same time. Another version here. This is actually going upwards. Steel is also being installed now. They are heavy as well. But as you can see on this photo, it's being brought down in two pieces, lifted up and then bolted together to minimise the lift weight that needs to be required for that working area. You know, to try and get really long, 3-4 metre pieces of steel down. Down the main tunnels, that's fine, but these are on cross passages or lift shafts that are being installed, or sub-lift shafts within the tunnelling industry. Something that we've tried at Barhale, and it works very well, and unfortunately I haven't actually got a photo that shows it on a timber heading. But in timber headings, you've got, in the past, you've got the rails that go in there, you've got a skip going in. The miners want the skip as big as possible, so that the number of times in and out, and when it's come out, they've got nowhere to, they can't do any more production, so they're stood there waiting for the skip to come back. So they're losing time, they're losing their bonus and what have you. But those skips, if you have a problem, and especially if you've got a full skip and the back plate is right up to the top, nobody from the front can get out. And that's a big issue. So skip sizes have been reduced so that people can get over the top, and the miners can't overload them. But what we've been doing here, this is a VAC-X. Now this is on a pipe jack. We did this up just north of Grantham. But here you've got a VAC-X, and we've got that hose going 30 metres up the tunnel. So we've got no skips going in and out. That TBM that was at the front there was an open face TBM, and we actually had skips of muck coming back out. So rather than have the skips come back out and the issue about safety and people getting in and out, we use this VAC-X. So VAC-X is basically a large, big vacuum cleaner, and it literally sucks everything. It can suck a brick up. It started off to be able to work on excavation, so you can excavate out and lift the material. But also what's happening now is that the smaller versions of this that are used for doing trial holes, so that people don't actually have to dig with any mechanical jigger or anything, and that removes the issue of possibly breaking an electric service and getting electric shock, or breaking a gas main or something. But here we've been using it in timber headings to be able to remove the material, but and the advantage being that you haven't had the skip in there, and improve the safety. Getting on to some very much more complicated items. Running tunnel in London. This was on the Piccadilly to Heathrow section in '73. So you've got two running tunnels. But quite often, you either need to install a crossover so that the trains can go from one tunnel into the other, or when you get to a station, you've put the two running tunnels all the way in, you then need to enlarge those two running tunnels into a big station area. So as you can see here, a very long process, but you go up, you take out that segment, just one segment of the running tunnel, you go up, and then you start driving a timber heading across. So that's the segment that's been taken out. That's the initial timber heading that's gone all the way across and goes across until you get to the other running tunnel. Then you go up again. Then you come all the way round, supporting it, and then you can take out that one ring. You're only taking out that one ring to start with, basically. Put in your new cast iron or concrete ring, and that gives you your station platform or your crossover. And once you've done one ring, you then start working your way up and down the full length of the crossover or the station platform. So you can see here, it's a long process going up through the roof, all the way across. And it looks like you're doing a big excavation across there, but you're just doing a narrow little timber heading from one side to the other, up again, support it all, timber it all across the top here, fully timbered and supported. And this will take weeks. So the design here has to be such to take load over several weeks. These originally were all designed very much by learning from the miners, repeating the same process. There was no real calculations in those days. It was all about perception. It was all done on slide rules and log tables. And, you know, Molam, which was a company that used to exist, don't anymore, they had a Bible of drawings, and they had a standard, and they used that every time. But all the way round, you can see the running tunnel here. So that's one running tunnel, not two, because that's just. Then the same on the other. Work your way round and then build in all the concrete or rings that form your new excavation. One of the things they used to say was, if it doesn't creak, it's been over-designed and you're wasting money. All these bits of timber can be cut on surface, ready for you. So they don't have to cut it down there. It would all be cut on surface. You'd have all the various pieces to make that design. You'd have all the wedges. And you'd make sure that those wedges are driven to be able to preload the excavation, the timber work, as you installed it. And you can see it's progressing here. So they've started back here somewhere, and they're steadily working along, installing these, taking out the section between the two running tunnels, and working their way across the top, supporting the face as they go forward, supporting the sides, and then installing the new ring. And you can see all the framework here installed to be able to run in the segments. There's a conveyor here, top conveyor to bring them in. And that's the result. And you can see the track there and how it materialises into a crossover. when you're on the station platforms and things in London. That's what's hidden behind everything. Another version here, similar sort of thing. You've got some sort of running tunnel, which is the initial main tunnel that's been driven by TBM. And then for some reason, this needs to be enlarged slightly for some reason. So this isn't a crossover. This is probably just a station platform, or, I don't know, to put some additional services in on the side or anything. I don't know what this one was particularly for. But you can see this has been enlarged from 5.7 to 7.5 metres. But the only way to do that is to do it with an arrangement of timber work. Photo on the right is underneath Hammersmith Tube Station, or the platforms. We did that project. That was a Barhale project done late 90s. They were wanting to build above the existing platforms. Hammersmith Tube Station used to be an open underground LUL station. But what they wanted to do was build the Coca-Cola building across the top of the platforms. And to do that, they needed to install some piles right in the middle of the platforms to be able to support the building as it came over. They could do it on the other side, but so we actually went down. We did it twice. We put a 5'6" shaft down, 5'6" meters diameter, 20 meters down. And then when we got to the bottom, we had to expand it out into a 20-foot tunnel that went about 20 meters in each direction. But you can see here all the timber work that gets put in, all the buttering up between the joints to stop it drying out, all the sideboards in here installed, and then they come in and they build a ring. Then they take all that timber out, advance it another, these were 610 segments, 610 mil, put it all in again and go through the whole process. And we did that twice on each of the bottom of these shafts. Put some rebar in the bottom, reinforcing bar, and filled the whole thing with concrete after we'd done it. So you can't see it, but it is literally, it was how to do a big pile right in the middle of a operational platform on a tube station. Other various ways of supporting steel supports here. You know, if you've got issues with settlement, if you've got buildings near above you that's going to affect the and you don't want the settlement from them. So there are other ways of putting in steel frames to help support the top as you're working your way forward. This was actually on a cross passage. So this is a cross passage between two existing tunnels that have been put in. So these are all the cross passages that exist between a north and a south line on any of the London Underground stations. Colour photo of basically what that previous drawing shows. Modern one, whereas that drawing was an old version, but yes, steel frames to hold up and support the ceiling. All this work used to be done on price work. You had a huge list of parts, as in bits of timber, and it was a continuous production line of moving forward, putting your timber in. A lot of the timber, the sideboards and everything were all on that. Those previous photos were all written off. That was all went and were left behind the tunnel segments and then grouted up. that's the a cross connection between two running tunnels. But this is a more modern version, and you can see here that what they've done is they've driven a heading across there from one side to the other, and they've concreted it up, so you've got a footing in there and a side wall. They've done the other one with a footing and a side wall, and the reason by doing it in two small bits is if you opened up all that area at one, you're very liable to have more settlement. So this is a way of mitigating the amount of settlement by going across in small little sections and getting permanent concrete support in there. And then once you've got your concrete support and it's all cured, you then go and take the middle section out. So that's designing timber headings so that you can install a very good permanent support. Just a different photo, and that's the lads at work nowadays doing exactly that bit of excavation. Still using the German jigger, that one looks like, but they will be rotating round, and the gloves are better, the ear defenders are better, lots of things are much, much better. You can see the support chain block steels here to lift everything. This is breaking out from a spray concrete lined tunnel, which is one of the new ways of lining excavations these days in London and around the world. But if you've got your tunnel going across this way, and this is them going across, putting in one of those concrete excavations all the way across, a timber heading across, and then filling this up with concrete. So at the moment they've got a conveyor here. You haven't got skips, you've got conveyors, you've got brocks, which are small little excavators in there to break the material down. There's lots of equipment now that's been designed to work in these small spaces and make it a lot easier for the workforce. Just showing the progress of one of those cross passages. Slightly different version here. They've gone all the way across, but instead of putting a roof in it of some concrete construction, they've put an arch of spun concrete spun segments across the top there. But you can also see this is part of the arch of one of the running tunnels. So this is putting a cross passage on top of an existing tunnel within a station probably. So that's taking out the top section, which isn't needed for the train to run into. But that's where what you can see there, and you can see it in the finished article there as well. Everything is now becoming digital with sequence drawings to show how you're going to get from A to B. So you can see here a cross passage, and then that cross passage is actually going up. So some of these cross passages then have lifts coming out of them, and you have to take that lift. So sometimes the lift are excavated not from surface down, but they're excavated from the cross passage up, because you're not necessarily coming out right on the surface, you're coming out in the ticket hall of an existing station. And then there's other ones here. That looks like that is some sort of excavation for possibly some sort of machine room, electrical room, and again, different ways of connecting and showing how the design progresses. Hand tunneling is slower, but it's perfect for certain places where you can't get machines. You can't put TBMs, and in London now there's so many tunnels and everything that are all cross-connected, and it's not just LUL ones, you've got all the post office ones. The power companies are all putting in tunnels everywhere now. The water authorities have got them. You've got Thames Tideway was put in from one end to the other. It ended up 70 metres deep at the bottom end because it had to go under all the other ones that are going across the Thames. Everything was going north-south across the Thames, but the Thames Tideway wanted to go west to east, and at some points it was gravity fed, and they've ended up 70 metres at the bottom to be able to get up under things that were 3 miles further upstream. Another one here, cross connection between a couple of shafts. Go and download the article from the BTS website, and it's very interesting to see and read all the comments and the notes that are on these, and fully understand the sequencing. This is probably a between, you've got a running tunnel here, and you've got some sort of connection lift steps possibly that were going to be installed, so you've got a cross passage, but you then needed to get down to the running tunnel, to the platform. So this would be excavated in timber, and then your step arrangements and everything would be put in concrete afterwards. Similar sort of thing, but you can see the amount of timber works it required to do a relatively small bit of work. And then you go back to the more basic things that are still done. This is a project my company did up at the Manchester Royal Infirmary. Sewer had broken somewhere underneath one of the big buildings, and there was no way of getting to that sewer that had split. The result being, you've got a timber heading here that then turned 90 degrees again, round various substructures to get to the point of where the repair was needed. And it's not the first one we've done. There was a swimming pool, I think it was in Sheffield. There was a leak underneath the swimming pool. Timber heading done, but not straight because of piles that had been put in to support the swimming pool. Nothing's ever easy. And a more modern drawing of a very basic timber heading. Fully timbered here, no side supports, one frame after the other, because for some reason it was going to be left for a duration, or there was something very critical above that couldn't. That was the Royal Hospital one. So yeah, it's all a question of supporting the ground. The work going on in some of that section. And then you've got a design check certificate to sign all this off. Another typical one. Handwork going around an existing running tunnel to enlarge it. For whatever reason they needed it that bit bigger. Thank you. And I'd like to, give a lot of thanks, especially to Colin McKenzie. He spent months is another version of our own Norman. He's the same version in the tunnelling industry that Norman is with writing books and everything within the mining industry, and the other ones that have worked on these sorts of things over the years. Thank you.
Well,
there we are. Absolutely wonderful, isn't it? So, you know, I can't imagine how in one lifetime you could learn all of that. It just seems amazing to me. But you obviously have, and there's a lot of other people doing the same sort of thing. So,
I think most of it you learn off the actual miners.
Yes, yes.
By far.
Yes.
Yeah. You might have arguments with them, but you also
well, I'm sure, yes.
learn most things off them.
Yes. Well, have we any questions from the floor? Right.
Cool.
Colin?
yeah,
Okay, I was with Shanty Goldfields in Ghana,
Right.
and on the exploration work we were driving short adits into laterite. By regulation we had to support the ground, although on site we had many old adits that were totally unsupported. We were in some areas that needed timbering because the ground was loose. Now, some of it was loose, some of it was hard, and when we were four-poling through, we had a great deal of trouble driving the headboards. We devised a system whereby the headboards were iron-tipped, and then we had the clay spades with a forked head to drive them. Were you doing anything like that in your experience?
Exactly. We don't normally put any sort of steel on the front. What we do is we just go and get a whole row of sheet piles,
Yeah.
for 1.2 meters long, steel sheet pile, put it up there instead of your headboard.
Okay.
And yes, we used to have a U welded onto the stub of an FL22 blade, and use that to drive the steel in. So you put a whole row of steels in if you can't drive it.
Exactly.
Yeah.
Yeah.
And the other thing is, timber heading is only good in relatively good ground. You can't do it in, you can do it in rock. You've got a lot of more grouting up and things to be done, but it's not really the, hopefully in rock you don't need to have to put timbers, but designers these days even want rock supported sometimes, even if you're only 1.2, 1.5 meters high. But the other thing is, it's not brilliant in water retaining ground. Sands and gravels aren't ideal, but it can be done. And what then happens in the front, you have what are called sand trays. So instead of letting the ground just fall, you have a timber across the front face. So as the material comes, it's actually supporting itself on the timbers. And then you move those forward as the ground, as you excavate forward and support the sides. But yeah, something very, very similar.
Thank you.
Any other questions from the floor? Norman.
Yeah.
Thanks, Daniel.
Ron, you haven't mentioned what type of wood you used. Was it softwood? Was it hardwood? Because in my experiences in mining, we use both for specific purposes. I just wondered, how you could actually manage to make sure that the pieces that you were taking underground were the exact right size, because in my experience, one of the most useful pieces of tool in a mine is a bow saw.
Yeah. And that is a problem everywhere. People try and get round things. In the past, it was creosoted timber, which you then had the cancer issues from. That's now stopped, and you've got treated timber, very similar to the treatments that goes on with house timber. It's all classed as C24, which is a grade. So there's a standard which gives you how many knots are allowed in a piece of timber. So C24 is the standard that any temporary works designer will put on his drawing, which is treated. In some cases it has to be fire retardant as well. So that's what's used now. That is a soft timber. The wedges are normally hard timber wedges. And there's so ideally it would be lovely if it was all hardwood, but this is temporary works in theory. And once the excavation's installed, once it's all sealed back up, grouted up, new pipe put in, segments, whatever you've installed, that's actually then just sealed. You've got no airflow, your limited amount of oxygen, and you don't get the breakdown of the timber. And you know, you can go back, if you go and connect back in onto some of these cross passages to do a new bit of work in London these days, you can find timber there that is near enough as perfect as it was on the day, because it's been sealed into an enclosed excavation. So yes, but we normally get all the timbers cut off site at the supplier, but yeah, you still do have the problems with the bow saw, definitely.
Any other questions? No, I think you've all enjoyed it.
No, there's one more.
Oh, here we are, Chris Calver.
Thank you. I sort of do a lot of woodwork, and I was going to ask a very similar question to Norman, but I just wanted to actually ask a little bit of a supplementary question to it. Is it mostly imported timber? Because I can't see us having the large balks of timber available in our own forests.
I don't know the answer to that one.
I'm sorry, but it was. I did think about it as thinking that it would add quite a lot of cost, because we would probably have to import it.
A lot of it's 8x6, 8x4, 8x2 for the various bits. You know, things like your polling boards, there's lots of different names for them, but they're all cut with a wedge on the front face to be able to drive them in at the top. So everything is pre-cut. But yeah, I wouldn't have thought so. I would say it would definitely come in, mainly probably I would expect from America or Canada.
Any more? No? No? Well, there we are. Absolutely wonderful. A few things I could say. And, coming from a mining area, there are slight differences between what you've been telling us about the styles that you're using for the clays and such like, as to what I'm sure Norman's experienced in the collieries up here. But there is a similarity, and I think the similarity is that everyone's learned from their experiences, and a lot of years have passed for people to learn so much about how to tunnel through different materials. And everyone has their own expertise as either a miner or a tunneler. And it's quite amazing the amount of technicality that's going in to designing a tunnel, and the ingenuity that's gone into a lot of the design of how you're going to do it, specifically the one where, you know, you wanted to go into another station and you go from the bottom up. I think that's, I would never have thought of going from the bottom up in a tunnel and having to work ahead above myself. But absolutely wonderful. But as you said, it's about experience. I can see the amount of safety that you take care of now. Obviously, looking at some of the pictures you had, actually some of those guys had very, very clean overalls on. But I don't know how that came about. But nonetheless, very confined spaces, very unsafe spaces, I've got to say. And never in a million years would you get me to do a job like that, I've got to say. So actually, on behalf of NEMI, your own institute, I'd like to thank you very, very much for the detail you've given us on this type of tunnelling, and it's been absolutely wonderful. I've learned a lot from it, certainly, and I've enjoyed it immensely. And I wonder if you could all show your appreciation in the usual manner. Thank you, everyone. I'll just get my phone out because there's a few things on there that I'd like to bring forward. Right, yes. One other thing I would like to say, actually, is I could say thank you on behalf of Duncan Summers.
Oh, right, yes.
He's my cousin. So, yes, there we are. We've come to the end of that particular side of things. And all we've got to think about is the next meeting, which is the 16th of April. And if my phone's right, it should be the History, Engineering and Maintenance of the Tyne and Wear Metro. Something that's close to all our hearts. I think every one of us has relied on the Tyne and Wear Metro quite a lot since it was built. So I'm sure you'll come along and enjoy it, listening to that one too. But in the meantime, make sure you sign the book, and we do get a little bit of money on the side from that. And take care on your journey home, and look forward to seeing you next time we're here. And also thanks once again to Rod for taking the trouble of coming all the way up here to give us this talk. Thanks, Rod.
So I've got to take the other half out for a meal now.
Thank you, everyone.